Good day, year 12. This session here is about polynomials and remainder theorem. Okay, polynomials and remainder theorem is in term 1, week 5. Okay, this note here. So if we go to the our notes, polynomials and remainder theorem. Now, simply, what is polynomial? Okay, polynomial is a function which is the sum of any number of terms where each term is of the form ax raised to the power of n. Okay, if you look closely here, where each term is of the form ax raised to the power of n. Okay, n can be any number. Okay, any whole number. Now, polynomials is an umbrella or a big family that a lot of equation comes under. Okay, for example, linear. Okay, x raised to the power of 1 is a polynomial family. Quadratic x to the power of 2 is a polynomial. Okay. Cubic equations x to the power of 3, okay, is a family for polynomials. Okay. Now, examples for polynomials is this. Okay, you have x cubed plus 4x minus 5, x to the power of 7, 2x raised to the power of 4 minus x cubed plus 1. Those are polynomials. Okay. Now, those which are not polynomials are whereby you have fractions like this, whereby x is in the denominator. Comparing with the first one, which is a polynomial, this fraction, x is in the numerator. So therefore, we could consider this as polynomials. Whereas for this, we consider this not a polynomial because x is at the denominator. Okay. Here, polynomials do not cover surds. Okay, surds. Okay, so this is not a polynomial. Okay, I hope this is okay. Now moving on. Example. So we move on to our example. Okay, for polynomial 2x cubed minus 4x squared plus x minus 12. The coefficient of x cubed is 2. Can you see that? Coefficient of x squared is negative 4. The degree of the polynomial is 3. Degree is the power, x to the power of 3. Okay, and the constant term is a negative 12. Okay, it is where no x is attached to the number. That's the constant. Okay, division of polynomials. Division of polynomials. What we do here is for division having this, okay, it is sensible to ask how many times x plus 1 goes into x squared minus 3x plus 4. In some cases, one polynomial does divide exactly into another. This will be the case if there is a common factor. Okay, for instance, we are given x squared plus x minus 2 on x minus 1. As mentioned here, how many times does x minus 1 goes into x squared plus x minus 2? So what we do is we factorize the numerator here. Okay, since it is in a quadratic form, we factorize that to give us x plus 2, x minus 1. Now, x minus 1 can cancel out with x minus 1. So these two will cancel out. Okay, these two will cancel out, leaving us with x plus 2. So again, this is a sensible answer. So it is x plus 2. So we can conclude that x minus 1 goes into x squared plus x minus 2 one time, which is this one where we cancel out. Okay. Moving on, part P, we have 16 minus x squared. Notice that 16 is a square number, x is a square number, so we have a difference of 2 squares. So a difference of 2 squares, is having a square minus b square, and to factorize it will be a plus b and a minus b. Okay, so in our example we are given 16 minus x squared. 16 minus x squared. So we say that 16 is a square number. How is it a square number? Since 4 is raised to the power of 2 gives us 16. It is a square number. And again, x raised to the power of 2, again, it's another square number. So 4 acts as our A, x acts as our B. So therefore, our A here is 4 plus B is x, and A here is 4, B is x. So now you have factorized this question. Okay, so this is what you have here: x, 4x plus x, 4 minus x. So when we cancel out 4 plus x and x plus 4 here, cancel this out, it leaves us with 4 minus x. Okay, so however, most polynomials do not divide exactly. There is a remainder. So what we've done in A and B, we are left with a remainder. Okay, we are left with a remainder here, a remainder here. Okay, good. Moving on. Describing what happens when 23 is divided by 5. Solution, we write 23 divided by 5 or 23 on 5. So 5 does not go exactly into 23, but it goes in 4 times fully with 3 left over. We call that 3 the remainder. Sometimes 23 divided by 5 is written as 4r3. R is the remainder. More frequently, we would express this answer as 4, 3 on 5. Okay, so just to give you a meaning here on our division process, we have dividend, the expression being divided, divisor, the expression doing the dividing, quotient, the answer, which is the number of times the divisor goes into the dividend fully, and remainder, what is left over. Okay, so in our long division form, we have this is a long division. Okay, this is long division. So what is here is our divisor. Okay, there you go. What's inside here is our dividend, and what's outside here is our quotient, and whatever we find and the leftover is here is our remainder. Okay. Now, how do you know if you are given an example like this? Okay, we are given an example like let's like this. Okay, wait. An example like this, whereby you have to find the quotient and remainder when x cubed plus 4x squared minus x plus 3 is divided by x plus 2. Okay, to find the remainder of that, x plus 2 goes outside. Okay, and then you have your dividend to be x cubed plus 4x squared inside here. Okay, so 4x cubed minus 4x squared plus x plus 3. Okay, there you go. Okay, let's look at our example here. There you go. Okay, now how do you divide? Okay, this is how you divide. Firstly, you look at the first term here. Okay, and then you ask, what do you multiply with x here? Gives me x cubed. Okay, so I multiply with x squared. X squared times x gives me x cubed. Yes. Okay, so then you write x cubed here. Okay, x squared times x gives me x cubed. X squared times 2 gives me 2x squared. 2x squared. Okay, and then we subtract. Therefore, subtract x and x cubed gives us 0. negative 4 minus a positive 2 is a negative, okay? Negative 4 minus a positive 2 is a negative 6, I think. Negative 4 minus negative 2 is a negative 6x square, 6x square, and then we bring down the x, so we have plus x here. Okay, the next question we ask is, what do we multiply with? What do we multiply with? What do we multiply with x to give us a negative x square? 6x square here, negative 6x square. Okay, so what do you multiply by that? We multiply by a negative 6x. So negative 6x multiply x gives us a negative, oh sorry, let's cross check this again. X square multiply x gives us a x cube. X square multiply 2 gives us positive 2x square. Okay, so then we have a negative 4x square subtract with a positive 2 gives us a negative 6x square. Yes. Okay, let's check it again. Let's check. So a negative 4 plus not plus subtracted by 2 gives us a negative 6. Very good. Okay, it's correct. Now then negative 6x multiply x gives us negative 6x square. Okay, negative 6x multiply 2 gives us a negative 12x. Are you with me? Okay. Then we subtract. Subtract negative this gives us a 0. 1 subtract a negative 12 is a positive 13x. Now let's bring down 3. So we have plus 3 here. Now what do you multiply with x gives us a 13x. So we multiply by a positive 13. 13 times x gives us 13x. Okay. And 13 times 2 gives us a positive 2 times 3 is 6, 2 times 1 is 2, it's a positive 26. Okay, and then we subtract, it gives us a 0 here, and then 3 minus a 26 is a negative 23. Okay, a negative 23. Okay, so our remainder, okay, our remainder is negative 23. Okay, if we expand this, okay, our remainder is negative 23. Our divisor, okay, is x plus 2. Our quotient is x square minus 6x plus 13. Okay, so from our answer here, we have it in quotient and remainder form. Okay, quotient and remainder form. So our quotient is this. Sorry, there's a mistake here. There's a mistake in our quotient here. Should be this one. Our quotient is x squared quotient plus remainder on divisor. So quotient here is x squared minus 6x plus 13. That should be here, which means it should be this one. Okay, but we have a mistake here, so it should be x squared minus 6x plus 13 plus remainder is 13. That's correct, and divisor is x plus 2. Okay, so this is called the quotient plus remainder form here. There you go. This is the quotient plus remainder form. Please make sure you take note of that. Okay, make sure you take note of that. Okay. Okay, moving on. The remainder theorem. The remainder theorem. Now, the remainder theorem simply means that we are given a factor, okay? We're given a factor, and then we use that factor, we substitute into the polynomial, okay? We substitute into polynomial to give us a certain remainder, okay? For example, I will go straight to the example. If you look closely here, we are given the example to find the remainder when x squared plus 4x minus 5 is divided by 2x plus 3. Now, what we do is for remainder theorem is the theorem states that we take what is divided, which is 2x plus 3, we let it equals to 0, okay, and we make x the subject. So x the subject, it will give us 3 this side and 2 to the other side. It will give us what we have here. So it will be a negative 3 on 2. Okay. Now, knowing your x to be negative 3 on 2, we substitute that into the, the, the polynomial x squared plus 4x minus 5. So x squared plus 4x minus 5. Okay. So wherever x is, you replace it with negative 3 on 2. Because since x here is raised to the power of 2, negative 3 on 2 will be raised to the power of 2 plus 4 multiplied by negative 3 on 2 and then minus 5. Okay, so this is what you have here. And then using your calculator, if you calculate and it gives you 0, then 0 means 2x plus 3 is a factor of this polynomial. But if it gives you an answer like for this example, it gives us negative 8 3 on 4, then this states that this is the remainder. Okay, okay, I believe that this is okay. Okay, okay, and that's it. Then you have your exercise there, and if you have any question, message me on Moodle, Facebook. If you have any question. Okay, thank you everyone, and that's our session for today, which we missed. Apology. Okay, that's our session. I hope this video session assists us well in our notes. Thank you everyone. Stay safe.